All right, so this is day one of target 3B, and we're going to be doing proving and applying theorems about lines and angles. So for your learning goals, you can use theorems about parallel lines to determine angle measures. We've kind of done this one before, so this is going to be more of a refresher than anything. Use theorems about parallel and perpendicular lines to determine information about other lines. This is really pretty easy. And then use my prior knowledge about angle congruence to complete a proof. This one is going to be the one that's going to be a little bit tougher, but you're going to get a lot of practice this key concept. So let's get right into it. Think about what we learned about parallel lines. Remember what I said, angles are either going to be supplementary, meaning they add up to 180, or they're congruent. So like if you look at B and D, right here and here, those angles are congruent because they're vertical angles. Okay, notice I'm going to be using abbreviations here. Hopefully you remember that this means congruent, and this is obviously angle. And then I'm going to get into a couple other symbols that you can use to kind of like shorten what you have to write. A and E, so these angles here, those angles are congruent because they are corresponding angles. All right. So you should remember that chart that you got last unit with all the different types of angles, corresponding, alternate interior, those kinds. I would refer back to that. Now E and D, so that's these two angles here. Okay, those angles are supplementary, and that's because they are same side interior angles. All right, and then A and G are congruent because they are alternate exterior angles. Alternate exterior angles. So notice how I abbreviated that. You can do that. So basically, alternate interior, alternate exterior, corresponding. So I can make a little list here for you. So these are all going to be congruent. Alternate interior, alternate exterior, vertical angles, all these are going to be congruent angles. Supplementary, meaning they add up to 180 degrees, those are going to be your same side interior, same side exterior. So like an example of same side exterior would be angle B and angle G. Those are same side exterior. And also adjacent angles. Okay, and this is all assuming that you have, you know, them on a line here like we have right here. Okay, like E and F, that's 180 degrees because the line is 180 degrees. So when they're adjacent and they're right next to each other, they're supplementary. All right, so let's look at this first example. Line L is parallel to line T, or line R, sorry, and you need to find the measure of angle 6. So remember what I told you. Forget about like worrying so much about like, oh, well, which types of angles are they? If you just start filling in, so if we do 180 minus 127, you're going to get 53. So we know that angle 2 is 53 degrees because those two are adjacent angles. 2 and 4 are 53 because they're vertical. This is 127. And then if we go down here, remember, same side interior, those are supplementary. So this is going to be 53 degrees, 127. So it's going to follow the same pattern here and here. Okay, so because of that, find the measure of angle 2, which like we said, they're supplementary, so it's 53 degrees. That should be 53. Pardon my math there. And angle 2 and angle 6, they're corresponding angles, so they're congruent. So the answer is not 63 degrees, it is 53 degrees. So the measure of angle 6 is 53 degrees. So no sum of angles here, just the measure of whatever angle 6 is. All right, a couple of things. In a line, this is a theorem. Don't worry about the number, but this is a theorem. Theorems are basically like rules. So in a plane, if a line is perpendicular to one of two parallel lines, it is perpendicular to the other of the parallel lines. So we've got this image here. Now a couple more symbols. This means parallel. And this is perpendicular. Okay? So we can show that with these arrows facing on these two lines. That means that these two lines are parallel. So that means that if a line is perpendicular to one of two parallel lines, so if A was perpendicular to B, meaning it forms a 90-degree angle, then it is perpendicular to this line as well, which is also a 90-degree angle. So remember, perpendicular means it equals, forms two 90-degree angles. All right, so second example, let me just go back real quick, make sure I didn't skip anything. Second example, we have if Charles Street, so this one right here, is perpendicular to Dana Lane, so this is perpendicular right here, and Dana Lane is parallel to Adams Court. So this line is parallel to Adams Court, which is this line. Then what must be true? Remember the theorem that we just said. So regarding perpendicular lines, parallel lines, Charles Street would also be perpendicular to Adams Court. That's it. You just have to remember that theorem, and if it helps, like I understand that this diagram might be a little confusing, so just draw it out like this. All right, and then make your marks on those. Might make it a little bit easier. All right, last example. So we need to complete the following proof. We're given that line L is parallel, so remember that means parallel, to line M. So these two lines are parallel. And we know that B, and we need to prove that B and G are supplementary, meaning they add up to 180 degrees. So this is what I was talking about, where you have to go through step by step and prove. This is kind of like what that project was that you were given. So you always write your given first. Whatever this is your first step. So your statement would be this. Your reason for it would be that you're given. Then you're told that angle B is congruent to angle D because vertical angles, and we know that vertical angles are congruent. Now, we know that D and E are supplementary. And D and E are supplementary, that's because they are same side interior angles. That's the reason why they're supplementary. We know that E and G are congruent because they're vertical angles. So we would write in angle E is congruent to angle G because vertical angles are congruent. And then this last step, angle B and angle G are supplementary, so that's basically substitution. We knew that angle E was congruent to angle G, all right, and we just needed to substitute G in up here. And you can do that because we knew that angle B was congruent to angle D, D and E were supplementary, so we just substitute that in. All right, and that's really all there is to it. I know that this problem here is going to give you some problems. Luckily, you're just filling in some blanks. So don't worry too much about it. We're going to get a lot more practice with it, and you will be fine, I promise. So anyway, that's it, guys. Have a good one. Make sure you take really good notes, especially on this particular problem.